Hey guys, the objective of today's video is to talk about principal stress, as well as to apply the concepts we learnt in the previous video to the Mohr circle. So let's say we have a similar element to the one in the previous video, except this time there are no shear stresses on the horizontal and vertical faces. By definition, these are then the principal planes, and sigma x and sigma z are our principal stresses. So the stress with the largest magnitude is called the major principal stress, and this is denoted by sigma 1. And the smallest principal stress is called the major principal stress. This is denoted by sigma 3. If we were to derive the expressions for the normal stress and shear stress for this element on a plane, we would end up with these expressions. Note how these expressions differ slightly from the previous video, because there are no shear stresses on the horizontal and vertical planes. The radius and center of the Mohr circle can be written in terms of the principal stresses like so. So here we have the Mohr circle, and I'll just quickly label where the principal stresses would go. So the maximum normal stress which is possible is sigma 1, that goes here, and the smallest possible normal stress is sigma 3 here. And of course the center of the Mohr circle would be located here, and the distance to the center of this circle can be found by the average of the principal stresses, and the radius is found by sigma 1 minus sigma 3 divided by 2. Now it is possible to calculate the normal stress and shear stress on any plane, as long as we know the principal stresses. However, it can be awkward to use the equations in practice because of the double angles, so we prefer to use a graphical procedure which involves finding the pole. So say you know the normal stress and shear stress on some plane in space. You can draw a line parallel to that plane through the coordinates of sigma and tau on the Mohr circle, and the pole is the point where the line intersects the Mohr circle. Once the pole is known, you can find the stresses on any plane. So if I was to quickly demonstrate this, so let's just say we have an element, and we know the principal stresses which are acting on it. So sigma 1 and sigma 3. So if I was to find the pole for this element, we will look at our Mohr circle, and so we know that sigma 1 is acting horizontally. So we go to the point where we go to the coordinate where sigma 1 is located on the Mohr circle, and we plot a line parallel to the plane through which sigma 1 is acting, which is a horizontal line. So as a result, where this line intersects the circle would be where sigma 3 is, and this is where the pole is. We could also find the pole in terms of sigma 3, so we know, for example, that sigma 3 acts vertically. So if we were to draw a vertical line through where sigma 3 acts, the pole would be located in the same location. And the reason why the pole is useful for us is because, say we're interested in finding out what the normal stress and shear stress are when the element is rotated at an angle of theta above the horizontal. If we know where the pole is on the Mohr circle, we can then project the line through the pole at this same angle, and that will give us what the shear stress and normal stress are at this point. Now something which is also beneficial to know, so from the center of the circle to the normal stress and shear stress at a plane, this angle from the center is 2 theta. So it's double the angle from the pole. And this is just the property from circle geometry. Hope this helps, guys.